your Python file here, I want to show you something. I'm going to start a program called PyCharm, and it might take forever. Alright, so this is just the welcome screen. What I'm going to do is I'm going to create a new project, and it's going to be a pure Python project. And what it has done is it has guessed at the interpreter, and it's guessed wrong because I have a million different interpreters installed here. So I'm just going to scroll and click the one. I don't want 2.7, I want something like, I think you said you were using Python 3, which is what you should be using. So I'll use this one. This one's my Python 3 installation. So I'll select that, and I'm going to tell it to put this project where I've already placed your file. The reason you want to, well, it'll be really clear why you want to use this. So here I've placed your file. Where have I put this? I've put it under Aaron. There you are. Open. Create. Do I want to create from existing sources? Yes, I do. Okay, here we are. I want to show you what this looks like. So under the project, it's really just the folder that contains your files. You can ignore basically everything else. So if I click this, double click that, it'll open up here. Double click that, there it is. So the great thing about PyCharm is it does all of this syntax highlighting, and it'll also tell you these tiny little formatting mistakes or errors that it thinks that it's found. It's really helpful when you're learning how to program. It'll tell you where all your mistakes are. There's also this cool thing called code folding. So when you have a big program here, you might have lots of maybe function definitions and stuff like that. And so in that case, you can collapse them, collapse the ones you don't care about. That's odd. I don't know what that's about there. And I think there's a presentation view. Yeah, it makes it huge. Okay, so here, let me just read through this. So you're inputting an integer. Now I wonder, can input, I don't know the answer to this, but can input, no, it just gives a prompt. All right. So never mind. I was thinking maybe you could tell it what is the type that you're getting out of it, but you're doing the right thing here. If you wanted to be super fancy, you could do something like this. So you could start with like, n is, I don't know, it's none maybe. So in Python you have this none type, which just basically means nothing. It's not set to anything. It'll define the symbol n, but it'll give it a value of none. It's like this special value that means nothing. And you can do this try, and then we'll try to set n to be the value of the input. But if I write the word elephant, that's not going to be able to convert to an int. So here you could do accept. And the accept part of it is what happens if there's an error, right? So accepts, you can say print. You must enter a number, and then I think I can do. Can I do return here, or can I do end? Oh, I don't know. There's a way to stop the program. Well, I can't figure out the way to stop the program. So if I do like -1, then what's going to happen is n needs to be at least 2, so you're going to get the error. If I put elephant, it's going to say you must enter a number, n needs to be at least 2. I think that's a reasonable thing to happen if there's an error. So look what's going on. You see this tiny little gray squiggle? If I hover over that, it's telling me, look, it's not an error, it's telling me something that I could do to make this better. And what it's saying here is, don't use just accept, because that catches any error. what you want to do is specify which error you want to catch. But I don't really care. I mean, to be honest, I do want to catch any error there, so this is really not telling me anything. But here, like here, there's a space before this parentheses. You don't want that space, especially if you're using Python 3 version 3. Get rid of that space. That just looks nicer for one thing. If you do something weird, like let's say that you're editing the program and, you know, as you know, Python, it really matters how it's indented. And so if you make a mistake and don't indent, right? So in this if part, you forgot to indent for whatever reason. It tells you, it gives you an error. It says indent expected, and there's like a little red underline. So that's why something like PyCharm is really nice. Okay, so n needs to be at least 2. I think that's a really good thing. Maybe we have to add that period in there. Yeah, it looks good. Okay, so now if n is at least 2, then you start off with making a list. So that's cool. I like that. And then you look at all of the numbers in a certain range. Okay. And so for each of those numbers, you do this business. Another stylistic thing, you know, put spaces around this. What I like about these you know, gray underlined squiggles is that it trains me to have really good coding style, right? So this good style in writing code is useful because certain sort of rules about how you format your code make it less likely that you're going to make a mistake. So here it's saying, you know, you can see here it wants you to put a space there. So I would probably write it like that. I like to put spaces on my operators, but that's just a personal choice. It doesn't really matter. And likewise, like the spaces here, they don't really matter. It's just you know, for this, it's just really a stylistic thing. It just makes it a little bit easier to read, but really, I mean, there's no functional difference. All right, so then we are going to go through and look at all of the integers from 0 to the length of this list, -1, I suppose. Okay, and then what do? We are going to so if n is not divisible by any of our primes, then C is exactly the length of our list. And so this is this case. So this case represents that. All right, so what I would say is I would put a comment. You should comment your code. It's always a good idea. So the comment is if n is not divisible by any primes in plist, add n to plist. And so that's what this is doing, right? And you might even do like this. Add n to plist, right? So here, so you're accumulating C. So what is C doing? The only thing that C checks is whether or not we've gone through the entire list and found that none of the primes divide n. So it seems to me there's probably a better way to encapsulate that. When this for loop is done, we don't do anything with the value of C except to check that none of these primes were divided evenly into m. Right? So I mean, like C is really a true or false. So maybe we could give it a better name. Call it nothing. I mean, I'm making this up. In Python, they tend to do what's called snake case. Nothing divides. You know, you do it with underscores, and let's set it to be true. And so if something does, if one of the primes does divide, we'll say nothing divides. And this is another great thing about this editor. If I start typing, it'll give suggestions. So let me start nothing, and that's the only suggestion. So this really eliminates, that doesn't eliminate, but it minimizes the number of typos that you make. So nothing divides. That's now false. Started out as true, but now it's false. Right? So, and then I can comment this out. I'll comment it out because you know it was in your original code, but I don't think it's necessary. No, I won't comment that. I want to break because that's all I care about. If something does divide, then I'm done with this for loop. But I don't need these two pieces anymore. And so this is now a lot simpler, right? This is if nothing divides, then then what we have is our new prime. So add it to the primes list. Okay, now why is this better? Well, because, well, first of all, this nothing divides has a meaning, right? This the value of this is either true or false, and so it has a meaning. The name itself, I mean, has a meaning. Another reason it's better is because, see here, like, it's confusing to count how many C's there are because you don't really care. All you care about is that you like found everything in here that is not evenly divisible by n is not evenly divisible by any of the primes. So so you don't care about that value. And like one last thing, you don't have to compute the length of this list. You don't have to compute the length of this p-list. All you need to do is just check if this is true or false, right? And if it's true, then add it to the list. So let me undo my changes. Let me run your original code. Now let me run it. I think I have to get out of this. View, is it? View. Exit presentation mode. So now there's this exit full screen mode here. Sorry. I want to run this thing. So run, and then run, and it'll ask me what to run. And this is the thing I want to run. Right. So it runs it. Enter an integer, at least 2. If I do elephant, it errors out. Now let me run it again. Because I've run it the first time, I now have it set. That's the thing I want to run. I can run it again. Or I can push this button, or I think it's Control R. Control R. Yeah, it's Control R. So let me do 8. Let's do 200. There, it's found a bunch of primes. Yeah, cool. I mean, I like it. It looks good. What would I change? Alright, so I've made another function here. This is just a different way of doing this that has some different trade-offs. So the way that you did it, you didn't have to create a list in memory of all of the numbers, even though it looks like you did. This range kind of looks like it's a list of numbers. Behind the scenes, this range doesn't actually create the entire list. It only creates whatever it needs in order to give the value to n. So your algorithm is a good algorithm, but there's an alternative choice to make, and that is to trade space for time. So your algorithm runs. I don't know. I haven't computed the running time. It probably would be not too hard to compute, but it has to loop over. It's probably n squared, right? It's a big n squared. It has to loop over all of these, but it also has to loop over all of the things in the list. Well, maybe that would be n log n. It's probably n log n, right? Because there's approximate. Well, I don't know. I have to think about it. You could figure it out. But how many operations does it take in order to like complete this list? So here's an alternative way is to create, and this is sort of the Pythonic way of doing this, to create a list of n elements long and fill that list with the value true. And so what I'm doing here is the index into this list is the number, and whether or not the true is sitting in that position, whether or not in the ith position we have the value true, that will tell me if I is prime. So that's what this list is doing. And so just like the most elementary way of doing the sieve is, you look at you just sort of cross off all the numbers. We're kind of going to do the same thing, except there's a little bit of a of an optimization that we can do to speed things up. So so now I'm going to loop over all at least all potential factors of numbers here. So I know that I only really have to go up to the square root of n, right? Because any factor of big N, any prime factor or any factor is going to be at least at most square root n, right? You can't have anything larger than the square root of n as a prime or even a composite factor of big N. And since that's true for any big N, it's true for all of the primes that we're going to find, or potential primes anyway, that we're going to find in this list. So we only need to go up to the square root of n. That's the first thing. And so what we're going to do is, if we've already determined that little n is a composite number, let's not bother with doing this check. Otherwise, what we're going to do is we're going to take we're going to look for all of the multiples of little n, and we're going to cross them off our list, right? So this is the cross off the list loop. Well, no, this is the cross off the list loop, right? And unfortunately, in Python, we don't have the kind of loop that I need here, so I'm kind of faking it. In C or C++, we'd have what's called a for loop, and it looks different from this. It's not this for loop; it's something else. But what I do is I'm gonna look at all these numbers, and these are the numbers I'm gonna cross off, right? So I'm gonna look at, but instead of starting at the very beginning of the list, I can start with the square of this number, the square of this little n, because the next possible number. I mean, it's the same reason that I only have to go to the square root of big N over here. It's just in reverse. The next possible number that might have this little n as a factor, the next possible one is this. So because we've already checked all the other factors below this little n, so I can start my loop for this n squared, and then I cross off. I'm gonna cross off n squared, but then I'm gonna cross off n squared plus n, and then I'm gonna cross off n squared plus 2n, and so on, right? So all of the multiples of this little n are gonna get crossed off. Now this is the cross off line. So I'm gonna set the index is the number, right? And so the value at index m, that's the, is it prime or not? And so here I'm saying it's false, right? So because these are all the numbers that are not prime, that are multiple, that have little n as a prime factor. And so I don't have this formula explicitly. Rather, I just add n, add n to the number m to get the next number, and I can stop whenever I get to the end, right? So whenever little m whenever I add the next n and it gets bigger than this big N, then that's when I can stop this loop. Okay, so that's what we're gonna do. Now when I'm done all of this, I have this is prime list, and it still has big N elements in it. And notice, by the way, it also has, like, it starts at index 1. Well, I guess it also has 0. It has index 0 and index 1. So maybe I need, like, because it's 0 indexed, now that I'm thinking about it, I need to fix this. It's 0 indexed, and so I want the index to be the number. And so I want to start at, I want the biggest index to be big N, and if we start at 0, then I need not big N elements, but big N plus 1, because I have that 0 element, the 0 index in my list of indexes for this list. So I need to do this. All right, so then I have this list of trues and falses, and every time I see a true, that index corresponding to that value is a prime number. And so the way I extract this is with what we call a list comprehension in Python, and it's a way of making a sublist. So picking out elements of a list according to some condition. And so I'm going to pick out all the integers I in the range from 2 to big N, but I'm only going to pick them out if I is prime. In other words, if when I put in I into this, I get the value true back. Right? So this is the sort of simple version of Eratosthenes. I can't even say his name, of the sieving algorithm, except with this, like, a couple of optimizations. And so this, like, even though we do have a memory structure that's big N long, actually a little bit longer than that, the running time is slightly better. I've also souped up our user input code. So what this does is, maybe I have too many lines there, I guess. What this does is it says, keep asking for input until the user just gives you nothing, until I just hit enter, in which case we can stop asking for input. And so now I can call my function, and I'm going to call, because I haven't run this code yet, I don't know if it works, I'm going to call my version. I've put your version into a function too, which is always a good idea, and for a lot of reasons. One reason is you can write a different version without commenting anything out. In Python, I mean, you should know functions. They're really easy to write in Python. This gray just says it's complaining because it wants another line there to make it more readable. So I mean, just go ahead and make it a function. Just get into the habit of doing that, because it'll make your life easier. Trust me. And it has an advantage. I've separated out my user input logic from the algorithm up here, right? So I've separated those two concerns. This kind of separation of concern is really common in programming. So let's see if I can run this. Enter an integer. So now if I do elephant, it complains. You must enter a number. All right, let's enter a number -100. N needs to be at least 2. All right, so let's do 30. And it looks right to me. Let's do 100. Looks okay. Let's do 1,000. I hope that's helpful. Let's see how fast yours runs. So if I do enter, it should end. And it does. Good. Let's see how fast yours runs. I don't know if it's going to be even perceptible. So if we do get primes, I'll call yours get primes. I'll just call it get primes. And so now I'll get primes there and run. And if I do 1,000, I can't detect any time difference. Maybe if I do like 1,000,000, 10,000, 100,000, 1,000,000. That's 1,000,000 is too many. Let's Let's try this again. 10,000. That's pretty quick. 100,000. Okay, so now let's do mine and see if it's any faster. I don't know if you'll be able to detect this or not, but let's try it. So it's 100,000. Oh, it is much faster, right? So see the difference. You know, those little trade-offs between space and time can make a difference. All right, that's it. See you later, man.